and we're talking about subtracting. A lot of times what they'll tell you to do is to convert to addition. That's an A, not a D. Okay, so if you convert to addition, basically what you do is you add the opposite. And so if you have a hard time with the subtraction, if you switch it to an addition problem, sometimes that makes it easier. I'm not going to start with A, I'm going to start with B. And if you look at B, I have -6 minus 9. That is the same thing as -6 plus -9. So in this case now I'm adding two negative numbers. You don't have to do this conversion if you don't want to, but if this is confusing and this is not, you can make it look in a non-confusing manner. So then I have two negatives, so I have the same sign, so I'll add them together and keep the sign the same. Okay. Same with D. I have 7 minus 10. That is the same thing as 7 plus -10. So I have two different signs, so I'll subtract. The 10 is larger, so that'll be -3. Now, we talked about the double negative, right? And I drew this for you, didn't I? Okay. So it's the same if we have a double negative with subtraction, it's the same idea. 4 minus -9 is the same thing as 4 plus 9. So that double negative becomes a positive. So we have 13. Okay, and it doesn't matter if there's a negative up front, it's the same idea. That double negative, he becomes a positive. And I don't know why it's a he, it just is in my head. So -11 plus 5 is -6. Hold true for fractions and decimals, so we have 3/20 plus 4/15. Now to add the fractions, I have to have a common denominator. So I'm going to look for a common denominator between 20 and 15. So I'm going to start with multiples of 15, because that'll be harder. So I have 15, 30, 45, 60. So 60 will work. So I'm going to multiply this times 4 to make it a 60. And then to turn 20 into 60, I have to multiply by 3. So that becomes 9/60. Then I can add them, and 9 plus 16 is 25 over 60. These will both divide by 5. And I'm going to get 5 over 12. With the decimals, that's the same thing as plus a -6.04. So these signs are the same, so I'm going to add them together. And when I add the decimals, I align them. So that's 8.34, but since they're both negative, it's negative. Translating with subtractions, difference of is going to be first minus second. Subtracted from is going to be second minus first. Decreased by, okay, this one is going to be decreased by the sum, but decreased by normally means first minus second. But this part right here means that all of this has to go in parentheses. And then 7/4 less than tells me second minus first. So that's just the order that those words mean. So on A, we have the difference of -7 and -5. So I have -7 minus -5. So that's -7 plus 5. Right. So that is opposite signs, so -2. And B is 12.4 subtracted from, so that's -4.7 first, minus 12.4, which is the same thing as -4.7 plus -12.4. Since they're the same sign, I have to add them. So I'm going to get 1, carry my 1, -17.1. C. Anytime you see an operator, either addition, subtraction, multiplication, or division words, and then it's followed by the word the, that tells me what comes after the goes in parentheses. So this is -24 decreased by, and then in parentheses, the sum of -10 and 13. So that's -10 plus 13. So I'm going to do this part first, because it's in the parentheses. -10 plus 13 is 3. So this is -24 minus 3, which is the same thing as -24 plus -3, which these are both negative. So that's -27. So just remember, this word the means to put parentheses. And I can, hold on. I erase this. I can fit D right down here. 7/4 less than 1/3. So that's going to be 1/3 minus 7/4, which is the same thing as 1/3 plus -7/4, and I'm going to need a common denominator. Between a 4 and a 3 is a 12. So I'm going to multiply that by 4 and that by 3. All right, so we've got 4 12s plus -21 12s. Opposite signs, so I'm going to subtract. So 21 minus 4 is 17. So I have -17 12s. And yes, it's improper, and no, we don't care. We're going to leave it just like that. What is the application of subtraction? So during one of his turns on Jeopardy, Harold selected the category show tunes. And he got the $200, $600, and $1,000 questions correct, but then he got the 400 and 800 questions incorrect. So we're going to write an expression that determines his score. Okay, so 200, 600, and 1,000 are correct, so those are all going to be positive. And then the 400 was wrong, and the 800 was wrong. I like to add all the positives together first, and then add the negatives together, since I know I'm adding, since they match. You don't have to, I just like to. So 200 and 600 is 800, and 1,000 is 1,800. And -400 and -800 is -1,200. And then since they're opposite signs, I'm subtracting, and so poor Harold only gets $600. And we have multiple grouping symbols. We start at the very inside and we work our way out. So we're going to start inside here. And then we're going to work our way out. So everything else will be the same. And this minus and negative is going to become a plus. Then I can add those together. So 7 plus 4 is 11. That's not great. There. And then I work inside these braces. 10 plus negative 11, or 10 minus 11 is negative 1. So this is the same thing as 10 plus negative 11. And you can look at it either way. Negative 6 plus negative 1 is negative 7. A square root is a grouping symbol. It counts as both a grouping symbol and a parenthesis, or I mean as both a grouping symbol and as an exponent. So you do everything inside of it first, and then you have to take the square root of it next. So first we'll do everything inside. So that's going to be 35 plus 14, and then minus 2. Right, because he's happy. And 35 plus 14 is 49. And then the square root of 49 is 7. And then I can, 5 minus 7 is negative 2. And negative 2 minus 2 is negative 4. And again, if this is confusing, you could think of it as 5 plus negative 7 and negative 2 plus negative 2. Because they both have the same rules. If you have matching signs, so 2 negatives or 2 positives, you get a positive answer. And if your signs don't match, so you have one of each, don't math, they always math, then you get a negative answer. And this is true for both multiplication and division. And we have 2 of the same sign, so negative 8 times negative 4. 2 negatives gives me a positive. And this is the same thing for decimals. 2 negatives give me a positive, and I am going to cheat. I can't see, 4.25. Okay, so 2 negatives gave me the positive. See, however, I have 1 negative and 1 positive. So my signs don't match, so that's when I'll get the negative. Okay, D. Nice trick if you multiply, I might have shown you this already. If you multiply a fraction times a whole number, check to see, does this number divide into that number? It does, so 2 goes into 8 4 times. And then multiply 1 times 4, and it's a positive times a negative, so that's going to give me a negative 4. Anything times 0 is 0. 0 is neither positive nor negative. And if I have negative 2 sevenths times negative 7 halves, I'm going to get a positive number. 7 and 7 will cancel each other out. They cross cancel. They both divide by 7. And 2 and 2 both divide by 2. And so I'm 1 times 1 over 1 times 1. So that's just 1. Here's why this works. Every time you have 2 negative numbers multiplied together, it gives you a positive, right? And so for every pair of negatives, if you're multiplying a long string of numbers, every pair of negatives give you a positive. And so if you count up all of the negatives, in the string of numbers, you count the negatives. If it's an even number of negatives, they're all going to pair off and give you positives. So you get a positive answer. If you have an odd number of negatives, you're going to have a bunch of pairs and one left over. And that one left over makes your whole answer negative. So if you have a long string of multiplication, okay, multiplying all that together. If I count up my negatives, so 1, 2, 3, 4, 5. I have 5 negatives. So my answer is negative. And then I no longer have to think about the signs. Now I can just concentrate on multiplying the numbers. And it makes it so that you're less likely to make a mistake on your signs as you go through the problem. Right? So because otherwise I would be going, okay, 2 times negative 3 is negative 6, times positive 4 is negative 24, times negative 6, you're going to have to keep track of when I was switching. Whereas if I count them up and I go, okay, my answer is going to be negative, then I can just go, okay, 2 times 3 times 4 times 6 times 8 times 10, down the list, and not have to think about it anymore. If I added one more or took one away, I'll make that 10 positive instead. I now have 4 negatives, so my answer will be positive because I have an even number of negatives. If I have an even exponent, actually, you know what, before we do this, let me add a thing. Okay, exponents. First of all, there is a difference between this and this. Okay. Negative 2 squared versus in parentheses. Yeah. This with the negative out front is negative and then 2 times 2. That negative is not being affected by the exponent. Exponents only affect what they're directly touching. So this negative right here is just hanging out. It's just there. It's a lurker. This is negative 2 times negative 2. So outside of the parentheses, I get a negative answer. Inside of the parentheses, I'm getting a positive answer. Now, what happens when we have multiplication and we count up all the negatives? That same rule applies if we have exponents. If I have an even exponent, then I have a bunch of pairs being multiplied together. So if I have a negative number inside of parentheses with an even exponent, I'm going to get a positive answer because they'll all pair off. If I have a negative number with an odd exponent, so I have a negative number with an odd exponent, I'm going to get a negative answer. That's when it's inside the parentheses. Now, if I have no parentheses, so if I have a negative number to any exponent and there's no parentheses, well then this will be a negative answer. Because this negative out front is not even being affected, it's just hanging out. If I have this in the parentheses then it'll be positive because I have a negative in a parenthesis to an even exponent, so that'll be positive 25. I have a negative outside the parentheses, so it'll be negative 25. Now, fractions inside of exponents, there are two ways to look at this. We can look at this as, hold on a second. That gives me negative 1 to the third over 2 to the third. I can look at it like that, where I kind of distribute the exponent. And if you're good at exponents, then that's going to be negative 1/8. And the reason I know it's negative is because I've got odd exponent. Or, if that's confusing, this is the same thing as negative 1/2 times negative 1/2 times negative 1/2. Because I'm taking it to the third, so I'm multiplying a half times itself 3 times, which gives me negative 1/8, because I have an odd number of negatives. So however it makes sense to you.
So whether the negative is within the bracket.
Okay, it'll be 0.4 times 0.4 times 0.4, and this is going to be 1.6 times 0.4, so that's going to be 0.64, I think. Let me just double check myself. Oh, 0.064. I was so close. 0.064. Dividing follows the exact same rules as multiplying. So if I have a positive divided by negative, my signs don't match, so my answer is negative. So 200 divided by 10 is negative 20. Negative divided by a positive, so 48 divided by 16, I'm going to get a negative 3. Negative divided by negative is a positive, and I want to say 5. So if I do 6.25 divided by 1.25, oh, I was right, it is 5. Okay, cool. So it's positive because I had negative divided by negative. And negative 9 divided by 5. I can do two things here. I can leave it as a fraction and just make it positive, because a negative divided by a negative is positive. Or I can actually do the division and do 9 divided by 5 and turn that into a decimal, 1.8. These are both correct. What is not correct is negatives in both the numerator and the denominator. This is not correct. This is fine, or this is fine. 0 divides by everything. This is the same as 0 divided by any number, or 0 divided by any number, like this. These are all the same. So 0 can go on top, or in front, or underneath. No problem. And the reason being is because division using a fraction, I'll show you guys. Do you guys all agree that 6 divided by 3 equals 2? Yes, good. Okay. That means that 3 times 2 equals 6. A times 0 equals 0. No problem. Where you have a problem is here. So this would be the same thing as A divided by 0, or 0 on the outside. And the reason we can't do that is because if I say 5 divided by 0 equals what? I need to find a number to go here that 0 times some number would equal 5. It doesn't exist. 0 times everything is 0. No, because imaginary is the square root of -1. This simply does not exist. 0 times any number equals 0, so 0 times nothing will give me 5. There's no number that I can multiply 0 times that and get a 5 or anything else. So that's why it's undefined. So anytime you see that, if I give you a problem like this, your answer is this. Okay. If I give you a problem like this, your answer is 0. 0 on top, okay. 0 on the bottom, no. All right, so order of operations, we do parentheses first, then exponents, then multiplication or division in order from left to right, and then addition or subtraction. Parentheses doesn't mean this, though. Parentheses is when you have like operations inside the parentheses, like that. This is just because this is for visual separation, because you wouldn't write 8 divided by -2. It's too confusing, so they put parentheses around negatives just to make them look nicer. So the first operation we come across that is in our order is division. So we'll do the division first. So I get -8, and then 8 divided by -2 is -4, and then divided by -6. And then I have to do this division next. Okay, so I'm going to put that back in parentheses and put a plus there. -4 divided by -6. Well, I'm going to write it this way, and that's going to give me positive 2/3. I'm taking this -4 divided by -6, and I'm rewriting it in fraction form. Yes. We have this lovely fraction. And in order to add this whole number to this fraction, I need to convert this to a fraction. I can put a 1 on the bottom. We can start that way. And then I need a common denominator of 3. So I can go -24/3 plus 2/3. And -24 plus 2 is -22/3, and I leave it just like that. Now the other thing I could have done, just as an alternative, if I want to convert this to a fraction, I choose a denominator. Okay, so that's the first step. I choose the denominator, and I want my denominator to be 3. So then I multiply by the chosen denominator. And make that the numerator. Okay, so instead of 8, I can say, okay, I want 8 to be thirds. So I want 8 to be thirds, so I'm going to say 8 times 3 is 24. And I can skip right to that step without having to write this middle step in. So I can choose any number. Like if I have 7, let's say, and I want to make my 7 into something fifths. 7 times 5 is 35. So 7 is 35 fifths. If I have -13, and what do we want my denominator to be? Give me a number, any number, I don't care.
5.
I just did 5. Okay, fine, I'll do 5 again. 13 times 5, 65. So -65 fifths. So So that's how you can convert a whole number into a fraction with any denominator you choose. So what we're going to do, first of all, this fraction bar is division. And it is going to be the last step because I need to do everything on top, everything on the bottom, get those down to one number each, and then divide. Okay? So what I'm going to do is I'm going to rewrite this so I can kind of move sideways. I think it'll be visually easier to see what's going on, I hope. Okay, I didn't change anything. 2 times the absolute value of negative 12 plus 3. Okay. So the first thing I need to do is the innermost parentheses. And I can also add in my absolute value. So I get 24 minus 2 bracket negative 3 plus negative 3 squared on top. And on the denominator, I get 2 times the absolute value of negative 9. Okay, so I did the first step in each of the numerator and the denominator. Okay, the next thing I'm going to do is I'm going to take the absolute value of negative 9 and I'm going to add inside the brackets.
So, excuse me.
Yeah.
Before you go on.
Sure.
I noticed that in the numerator.
Uh-huh.
That you change the 5 minus 8 into that negative 3 plus. Sorry. Like, how did you change from the top step to the...
Negative, okay, this is exactly, this right here is exactly right here, right? 24 minus 2, bracket negative 3 plus 5 minus 8 squared. So all I did from here to here is 5 minus 8 is negative 3. Does that,
Oh,
so I combined those two and got this negative 3.
yes, basically P.
Yeah, just that's exactly what I'm doing. So then on my next step, I'm going to do this negative 3 plus negative 3. So everything else will stay the same, but negative 3 plus negative 3 is negative 6. So that's all I changed. I took these two and put them together. And in the denominator, the absolute value of negative 9 is positive 9. Okay. Okay, so next I'm going to square the 6, or the negative 6, and then multiply the 2 times 9. So this will be 24 minus 2 times positive because it's inside, so it's times 36. And 2 times 9 is 18. Okay, which I'll rewrite down here. I'm not changing anything, just rewriting for continuity. The next step I have to do in the numerator is this multiplication. The denominator is done. So 24 minus 72. 18 stays the same. And then I do 24 minus 72, which I'm sure I could do, but I don't feel like it. So I get negative 48 over 18. Now 18 does not go into 48. So at this point I have two options. I can reduce or I can divide. Okay. If I reduce, I'm going to see, yeah, I'm going to keep the fraction. I'm going to ask myself, what is the largest number that goes into both 18 and 48? 18 divides by 2 and 9 and 3 and 6. 48 divides by a bunch of numbers, 12 and 6. So I'm going to do 6. So if I divide each of these by 6, I'm going to get 8/3. Right? Or if I do division, I'm going to do, negative 48 divided by 18. And I'm going to get 2.6 repeating. These answers are both correct. The fractional answer is more correct. And the reason it's more correct is because it's exact. This is rounded. Because I can't actually write 2.6 forever. I'd still be writing. You guys come back 60 years from now and I would still be writing. So this is more accurate, so it's technically more correct, but they're both correct. It's just the 8/3 is a little bit more correct. Just a little bit, not much. Just it's more accurate. Okay, when you're given evaluations and you have something like y squared or x squared, and the value they give you is negative, put it in parentheses because the y is being squared. So that means the whole thing is being squared, which means the negative is also being squared.
Say that again.
So here y is being squared, right? And y is negative 6. All of y is being squared, which means that negative is also going to be squared. So just get in the habit of every time you replace a variable with its value and the value is negative, just throw it in parentheses just to get in the habit, and then you'll never make the mistake. And so that's going to be positive 36. David, stop. Here I have a negative hanging out front, so that negative just hangs out. And then I get negative 6 squared. Now, this is not the happy man. Because I have to do the exponent before I do the, so I have to do this exponent first, which gives me a positive 36, and this guy just hangs out. Okay, so be really careful of that. You have to do exponents before you do multiplication, and when you change the two negatives to a positive, you're really multiplying by negative 1. And while I'm on the subject of things that you can't do, if I have a negative outside of parentheses like this, that negative could slide in there, right? And that makes this a positive 4. However, if I have a negative hanging outside of absolute value, and there's no sliding in, you bam into a wall. You can't get past that wall. So that negative doesn't go away. I cannot multiply into absolute value. I can multiply into parentheses because I can slip around the corner and slide in there, but absolute value is a wall. I cannot multiply in. I can only come out.
Absolute value means business.
It does mean business. Commutative property is like your commute. You go from home to work, from work to home. All you did was change direction. So commutative property changes order. Okay? So A plus B is the same thing as B plus A. 2 plus 3 is the same thing as 3 plus 2. It doesn't matter what order we add in. Adding is adding. Same thing with multiplication. 4 times 3 is the same thing as 3 times 4. It does not matter what order we multiply in. You'll notice subtraction and division are not here because those do matter. 3 minus 4 is not the same thing as 4 minus 3. And 2 divided by 5 is not the same thing as 5 divided by 2. So commutative is only adding and multiplying. So to rewrite using commutative, you just change the order.
Yeah.
So I have to change this to addition first before I can apply commutative property to it. So then that becomes negative 3b plus 5a. because I can't switch the order of, I could not, this is, do not, okay, 5A minus 3B is not 3B minus 5A, right? So you have to make an addition before you can change the order. Negatives or subtraction signs, they're like your shoes. You don't go anywhere without them. So they stick with the 3B.
How is this useful?
Oh, well, because when you have a problem with a bunch of stuff happening in it, you can rearrange the problem to put things together that are easier to do. For example, multiplication. Just an example of why you'd use commutative property for multiplication. If I have 2 times 5, here, let's do that to make it times 13. No, wait, that's not what I meant to do. 2 times 13 times 5. So if I did this in order, I'd get 26 times 5. I don't know, 26 times 5. But if I do 2 times 5 times 13, I do know 10 times 13. So I could just rearrange the problem to make it make more sense. I could, if I have a bunch of addition and subtraction going on, I can move it so that all the positive numbers are together, all the negative numbers are together, so I can combine those first and then combine the positives and negatives. And then if we're going to rewrite these, this would be negative 6 times 12, and this would be 4x. You don't have to copy that down. Okay, associative property changes grouping. So associations are groups, right? So I can add these two. So if I did addition, so 1 plus 2 plus 4 is the same thing as 1 plus 2 plus 4, right? This is 3 plus 4 is 7. This is 1 plus 6. It's still 7. Same thing with multiplication, and a lot of times the reason you change the associations are to make it easier. So if I did 5 times 2 times 19, well, it would be easier to multiply 5 times 2 first and then multiply that by 19. So you just change the grouping. So here, the point of changing the groups is I make that y plus 5 plus 6. And I can add that together, so that's y plus 11. This is multiplication. I can change it to 4 times 5 times z. So that's 20z. And here I can change this to negative 3 halves times negative 2 thirds and then times w. So that's just w, because negative 3 halves and negative 2 thirds are going to cancel each other out. Right? The 2's and the 3's will cancel. Okay. So, identity. Your identity is who you are. So the identity properties do not change who you are. So the identity property of addition is to add 0, because anything plus 0 is just itself. 0 didn't change anything. And that makes 0 is the additive identity. And the identity property of multiplication is to multiply by 1, because if you multiply by 1, you didn't change anything, and that makes 1 the multiplicative.
What?
Shh, honey. So multiplicative identity.
I have no idea what you're talking about.
Honey, shh, please. Inverse properties. Inverses take you to your identity. So A and negative A are inverses of each other. So when you're talking about addition, it's opposite signs. So addition and inverses are opposites. And multiplication inverses are reciprocals. Reciprocals. Okay, because if I take b, b is the same thing as b over 1, right? So the reciprocal is 1 over b. So anytime you have a normal fraction, you just flip it over. These would be inverses of each other. So these would be multiplicative inverses, and then say 2 and negative 2 would be additive inverses. The distributive property of multiplication over addition, otherwise known as just the distributive property. We don't usually say the whole rest of it because, again, mathematicians, lazy. So we just say distributive property. And what that means is we're going to take whatever is on the outside of the parentheses and we're going to multiply it by whatever's on the inside of the parentheses.
This is what's used the most.
This is used definitely the most. So if I have a 3 and I have a 2x and a 4, I'm going to take that 3, I'm going to multiply it by the 2x, and I'm going to multiply it by the 4, and I'm going to get 6x plus 12. And if it's on the back, that's fine. You just do this. Same thing. So I can do that, and it doesn't matter how many terms are inside the parenthesis. I'm going to take this 2 and I'm going to distribute it to each of the terms inside. So I get 2 times A, 2 times 6B, and 2 times 7. And I'm going to distribute 24 to each of these. And the reason I picked these numbers is because it'll be nice. 3 goes into 24. 4 goes into 24, and 8 goes into 24, right? Do you guys all agree? So what I'm doing here, 3 goes into 24 8 times. 8 times 2 is 16.
Do they all have to go into 24?
No, I'm just doing an easy one to start.
So that's like you're kind of doing the over one.
Yeah. 4 goes into 24 6 times. 6 times 1 is 6. And then 8 goes into 24 3 times, and 3 times 3 is 9.
Okay, well, that's good. So what about if the number on the outside is not matching all the bottom? Is that-
Okay. 3 goes into 15 5 times. 5 times 2 is 10. And 4 does not go into 15. 15 times 1 is 15.
Oh, so you keep them.
8 does not go into 15. So 15 times 3 is 45.
Denominator stays the same.
The denominator will stay the same. So if they divide, it's nice and pretty. If they don't divide, you just multiply times the numerator. Okay, 3 goes into 6 twice. 2 times 2 is 4. 3 goes into 15 5 times. 5 times 2 is 10. And 3 goes into 18 6 times. 6 times 2 is 12. So it's the same idea, except you're dividing by 3 each time.
And if you have a fraction inside and outside, you multiply, right? Multiply the fraction.
Plus 9, something like that. Yeah, so then I'm going to multiply 2 times 1 and get 2, and 3 times 2 and get 6. And then 3 goes into 9 3 times, and then that times 2 gives me 6. So if there's fractions, you multiply the fractions together. I mean, really, I'm multiplying the fraction times the whole number as well. It's just that the denominators divide if possible.
Excuse me.
Negative outside the parentheses, you distribute that negative, and all it does is it changes all the signs. So becomes positive 3a, negative 2b, negative 5c. If there's a negative 6 outside, you have to multiply both by the negative. So if this is negative, you have to carry the negative in as well. So this becomes negative 12, positive 24x. Okay, and that's really important, especially when we get into solving equations.